Hi and welcome to the lesson of multivariable calculus. So today we are going to discuss tangent planes and normal lines. Now we are already familiar with the equation of the plane that is given by a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals to 0, where ABC is the vector that is perpendicular to the plane and the point x naught, y naught, z naught is point that is contained in the plane, right? So these two things we uh, need to know when finding the equation of the plane. So first of all, let us discuss what is meant by a tangent plane. Now we have learned in calculus course that if we want to draw a line that touches this point on the curve, that is on one and only one point on the curve, so the line which touches this point is called a tangent line, tangent to this point, right? Similarly, in space, that is in three-dimensional space, if we have a surface, then we can say that a plane that is touching one and only one point is called the tangent plane to that point. Now, if we are interested in finding the equation of this tangent plane, we need to know the perpendicular vector to the plane and the point that is contained in this plane. All right, so now let us see how to find this uh, equation of the plane. Now see here, we have a question that find the equation of the tangent plane and normal line. So first we'll talk about the tangent plane, and the equation that is given is the ellipsoid, and we need to find the tangent plane that contains this point, right? So first of all, let us talk about the perpendicular vector that we need to find for this tangent plane, right? So we need a perpendicular vector, right? Now this vector will be given by the gradient of this function, right? So gradient is basically the vector that is perpendicular to the tangent plane, that points perpendicularly outward to the plane, right? So the gradient of the function is basically the vector that is the partial derivative of f with respect to x plus partial of the function with respect to y and the partial of the function with respect to z, and it is given in this form. It's a vector, right? So in order to find the gradient, we need to find the partial derivatives of the function. Therefore, the partial of this function with respect to x is 8x. Partial of this function with respect to y is 2y, and partial of this function with respect to z is 8z, right? Now, this is the gradient function, gradient vector, right? That is 8xi plus 2yj plus 8zk. But we are interested in finding the gradient at this particular point that is given 1 comma 2 comma square root of 2. So we need to plug in these points. So this is the x coordinate, that is 1, that is actually x naught, and y naught is 2, and z naught is square root of 2. Now when we plug these points, we find the gradient at the point that is actually 8i plus 4j plus 8 square root of k. All right, now we have the gradient of the surface at this point. Now this is actually the perpendicular vector of this tangent plane, right? Pointing outward like this. So this is the gradient, and the point is already given, that is this point 1 comma 2 comma square root of 2. So we have the point, we have the perpendicular vector, so we need to just plug in the equation of the plane that is given by a times x minus x naught b times y minus y naught dot 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 equals to 0, right? Now the perpendicular vector we have found is 8 comma 4 comma 8 square root of 2, and the point P naught is given as 1, 2, and square root of 2. So when we use these points in this equation, we will get the following result, that is this result, right? So this is the equation of the tangent plane. Now in order to find the normal line is actually a line that is passing through this plane perpendicularly like this, that this is passing through the plane like this, right? So this is the normal line. Now to find the equation of the line, we need a point. We need a point on the line, and we need a vector that is parallel to the line, right? So we already have the vector, that is the gradient vector, and we know that it is perpendicular to the plane. Since the line is also normal to the plane, that is perpendicularly cutting the plane, therefore the vector that we already found as a gradient vector, it is parallel to this line, that is the normal line. Therefore we can use this vector to find the equation of the normal line. Therefore we know that the parametric form of equation of line is x equals x naught plus at, y equals y naught plus bt, and z equals to z naught plus ct. And also the symmetric equation is given by this expression, that is this expression here, right? So we have this vector ABC, that is the parallel vector to this normal line, and we have the point 1 comma 2 comma square root of 2, and we just need to plug these points here, and we are going to get this equation, that is actually the symmetric equation for the normal line, right? So this is how we find the equation of tangent planes and normal lines. So hope you guys understand this lesson. Thanks for watching the lesson, and that's all for the time being.